What if I told you there's a way to connect remote networks without expensive MPLS lines? Most network engineers waste thousands on leased lines, while GRE tunnels can do the job for free. But here's the catch. GRE isn't secure by default. In this video, I'll show you step by step how to configure a GRE tunnel with OSPF routing and make it secure. Stick around, this could save your company thousands. In this lab, we will see the configuration of a GRE tunnel. This tunnel, developed by Cisco, is an encapsulation process, which allows any protocol from the network layer to be carried in packets that are themselves from the network layer. That is to say, we can, for example, encapsulate IPv6 in an IPv4 packet in order to make two distant IPv6 networks communicate. The downside of this protocol is that it's not secure. The data flowing through it is not encrypted and there is no authentication at the ends. So, it is still possible to add a layer of security by running the GRE tunnel through a VPN tunnel. In this lab, we're going to create a tunnel between routers 1 and 4. We can see this tunnel as if we were pulling a physical cable from router 1 directly to router 4. The only condition to be able to create this tunnel is that these two routers must first be able to communicate. To start, we're going to check that our topology is ready to host and run this tunnel. We connect to router 1 and we will check its routing table with a show IP route. Here, we see that it doesn't run any dynamic routing protocols. It only has a static route, which tells it to forward the traffic that would be destined for the 10.0 or the 0.0 network to the interface that carries the 10.10 1.2 IP, the one that is located at the other end of its Ethernet 1x1 port. We now check the router at the other end, i.e. router 4, with the command show IP route. Here, we see that we have the same thing as router 1, but in the other direction. If we go back to router 1 and try to ping router 4 with a ping 10.10.3.2, the connectivity between these two routers works perfectly. We will now move on to router 2 and have it display its routing table with a show IP route. On it, we can see that it executes the AGRP protocol to process its routing. This can be seen with the symbol D and with the administrative distance of 90. Which corresponds well to the AGRP. So, since router 4 does not run the AGRP protocol, router 2 does not know the network behind router 4. That is, the 172.16.4.0 network. We'll check this by pinging from router 2 to the network behind router 4. It's not working, and it will be the same from router 1 to the same network. It's time to start setting up the GRE tunnel on router 1. To start, we're going to create tunnel 0 with the interface command. Then we put the IP 172.16.99.1 blue says a mask in 3 times 255.0 with the command IP address. Then it is specified as the source tunnel, the Ethernet port 1 tower 1. It is the one that points to the destination, and as the destination IP, we put the one of the router interface, which is located at the other end. Now, all that remains is to reproduce the same principle on router 4. It is made a tunnel 0 interface. We put the IP 172.16.99.2 with a 24-bit mask. The source tunnel will be its port 1-3, and the destination will be the IP of the 1x1 interface of router 1. That is to say, 10.10.1.1. We will now check the configuration with a show IP interface brief on router 4. This shows us that the status and protocol of tunnel are up on this router. We'll check the same thing on router 1 with a show IP interface brief. Here too, the tunnel is indeed UP. If you want to get more information about this tunnel, you will have to use the command show interfaces tunnel 0. With this command, one can see its source IP and destination IP. We will now go to the routing table of this router with a show IP route. Here, we can see the 172.16.99.0 network, which is directly connected to router 1, as if we had pulled a cable between it and router 4. And if we now try a ping to the IP at the other end, i.e. a ping 172.16.99.2, the ping was successful by going through the GRE tunnel that we just configured. The ICMP packets were encapsulated in the GRE tunnel. That is, from router 1 to router 4, the IP packet that leaves from 172.16.99.1 to 172.16.99.2 has been encapsulated in a second IP header that comes from 10.10.1.1 to 10.10.3.2. This packet originated from Ethernet port 101 on router 1 and was transmitted by router 2 and 3 on Ethernet port 1x3 on router 4. And when the latter received this IP packet, it deleted this second header to fetch the IP packet, encapsulated to 172.16.99.2. As for routers 2 and 3, they didn't know that there was a second IP header in the packets they were transmitting. The 10.0.0.08 network was used to forward packets for the 172.16.0.0 network, even if the transit routers had no knowledge of this subnet. This is what we saw at the beginning of the TP when we couldn't ping IP 172.16.4 from router 1. So currently this is still the case, because there is no routing protocol to configure for the tunnel network that we just created. If, from router 1, we reping to IP 172.16.4.1, it still doesn't work. We will therefore configure an OSPF routing that will carry the ID1 with the command router OSPF1. We put a router ID in 3 times .1, and with the network command, we add the network 172.16.0.0 with an inverted mask in 2 times 0.2 times 2.5 so that it wraps all the networks of router 1 and 4, that is, loopback, tunnel, and Ethernet 1.0 interface networks. And you have to do the same configuration on router 4, except that for it, you will put the router ID in 3 times 0.4. You can see the OSPF adjacency that goes up directly as soon as you add the network to it. Now, if we go back to router 1 and do a show IP route on it, this time we see that it has learned the route of the network behind router 4 and its loopback in OSPF. If we recall the ping command to 172.16.4.1, this time it should work without any problem. Ping works through OSPF routing. And that's it for the practical work on the GRE tunnel. To practice and assimilate the principles of this lab, you can remove all the equipment from the topology without touching the text and reproduce the network diagram from A to Z using all the information on the IPs and interfaces. See you soon in the rest of the training course.